Hey, what's up guys? Mr. Sproggy here. I'm going to be showing you my thought process about how to do the Parabola project. So to start off, I'm going to choose any equation. I'm going to go with y equals negative x squared plus x plus 6. This is in standard form because standard form is ax squared plus bx plus c. I can identify what my a, b, and c values are by looking at the original equation here. I know a equals negative 1, b equals positive 1, and c equals 6. As I'm going through this, I'm going to be referencing the grading rubric that I attached at the end. The grading rubric, the first thing it talks about the direction of opening. The direction of opening, let's draw a line here, has to do with the a value. If a is greater than 0, it is concave up. Remember that word, concave. And if a is less than 0, it is concave down. Okay. The axis of symmetry, I'll alternate colors. Axis of symmetry has to do with the line that goes through the center of the parabola, going through the vertex. In order to find this without graphing it, we want to use the equation x equals negative b over 2a. We identify what b and a were from above, so we know b is 1 and a is negative 1. Therefore, this gives us negative 1 over negative 2, which is positive 1/2. So my axis of symmetry is x equals 1/2. Next is the vertex. The vertex, once you've found the axis of symmetry, is going to be that x value 1/2, comma, what happens when you do f of 1/2. So this is function notation. What happens when we plug in 1/2 into our equation? Well, our equation is here. I'll go ahead and copy it. Okay, so we're going to plug in 1/2 into all these x's. So I'll get y equals negative parentheses 1/2 squared plus 1/2 plus 6. Remembering my order of operations, this gives me negative 1/4 plus 1/2 plus 6. Simplifying it, that gives me 1/4 plus 6, or 24 over 4. No, let's do common denominator here. Let's do 1/4 plus 24 over 4, which equals 25 over 4. And that's going to be the y coordinate of my vertex. So we found our vertex. The maximum or minimum value, that is exactly what the vertex is. So max, min, since this is concave down, our vertex is at the top, so therefore our equation has a max. We can say the max value of this quadratic function is exactly what we found in the last problem, 25 over 4. Our y-intercept is what happens when x equals 0. So in other words, f of 0 equals, we're going to do that same process we did when finding our vertex. We're going to do negative x squared plus x plus 6. Remember, when you're finding your y-intercept from standard form, your answer is going to be just that last constant. It's going to be 6. We can figure that out because we know it's negative 0 squared plus 0 plus 6, which equals 6. So therefore, our y-intercept is 0, comma 6. Our x-intercepts, it's a little bit different. If we start off with our y equals negative x squared plus x plus 6, we want to find our x-intercepts. We can do this by factoring. We want to figure out when does negative x squared plus x plus 6 equals 0. We're going to do this by factoring using the x method. Up top, we're going to have a 6, negative 6, because we have this negative sign. Don't forget about that. Negative 6, on bottom, going to have 1. So what two numbers multiply to get negative 6 and add to get positive 1? Looks like one's going to be a 2, one's going to be a 3. And since we're adding to get a positive 1, we're going to have a negative 2. So it looks like I should have x minus 2, x plus 3. And let's see what happens when I graph this. And because I have this original negative sign in front, I need to have another negative sign out front here. So what this does is this switches the signs of my inside roots. So instead I'll have x plus 2 and x minus 3. Therefore, my x-intercepts are negative 2, 0, and 3, 0. Some other points on the parabola or on the quadratic equation. We can see what happens when I plug in 1 and negative 1. Basically, what happens when I plug in other input functions. So we need to find 3 points on each side of the vertex. I'm going to go ahead and reference Desmos now. So I can type in my original equation, which was y equals negative x squared plus x plus 6. And I also had the factored form. That's when I was finding my x-intercept. This is y equals negative x minus 3, x plus 2. We calculated our vertex earlier. That vertex was 1/2, comma 25 over 6, which in decimal form, Desmos likes to do that. Gives us 0.5, comma 6.25. We also calculated our y-intercept, which was 6. And our two x-intercepts, which were 3 and negative 2. Okay. Right now, we need to find a couple more points. So I'm going to go ahead and use a table. And I'm going to leave, since I need to find 3 points on each side of the vertex, I'm going to, let's see if I can, I know my vertex is 0.5 and 6.25. So let's test the points. Negative 2, negative 1, 0, 0, and then those are on the left side of the vertex. And then now I should have 1, 2, 3. So what happens if I plug in negative 2 into my equation? I can do this simply if I copy this equation again, but instead of using x values, I type in the letter A. Let's do standard form. Let's do negative a squared plus a plus 6. Should be giving me a slider. There we go, let's use B. Okay, so if I say B is -2, then I get an output of 0. Okay, and we knew that because -2 was one of my x-intercepts. If I say B is -1, I get an output of 4. If I say B is 0, I get an output of 6, and we knew that already because that was our y-intercept. If I do an input of 1, my output is also 6. An input of 2 gives me an output of 4. And an input of 3 gives me an output of 0. If you look at this table, you'll see the symmetry in this parabola. I talked about this in class. It goes 0, 4, 6, 6, 4, 0, very symmetric. So I've therefore found 3 points on each side of the vertex. So let me go ahead and label the vertex. The vertex was at the top here. It was 0.5, comma 25 over 4. Label that. So there's my vertex, and I found 1, 2, 3 points on the left and 3 points on the right. I do really recommend using Desmos for this problem, for this project. You are required to draw it by hand, but Desmos really does help you understand where all the numbers come from, and it helps you calculate it. Okay, I really do encourage you using Desmos for this. Okay, so we found 3 other points. You guys need to now graph this by hand, either on graph paper or create your own graph, making sure you're using straight lines. And we can talk about 2 real-world pictures. So graph by hand. Make sure you include 2 real-world examples. And lastly, the extra credit is discriminant. Since this one is extra credit, I'm not going to fully explain it, but I will give you a hint. You want to talk about the value b squared minus 4ac. I want you guys to Google that. Google the word discriminant, and you should see something to do with b squared minus 4ac. I want you guys to write about 2 sentences that describe how you can use a discriminant to tell how many x-intercepts your parabola has. Your final project should be on one side of a piece of paper. Remember, you're just drawing one parabola, listing all of these properties. Make sure you reference the rubric so you know that you're completing all of the requirements. And I'll upload a picture of my example onto Google Classroom. Good luck.